Okay, in this section I'm going to talk to you about multiplying and dividing rational expressions. First of all, let's talk about multiplying. Because if you know how to multiply rational expressions, then dividing is easy. You just have to do one little thing before you start the division process. Okay, so step one, we want to factor all numerators and denominators completely. Usually that's generally done if there's more than one term in the numerator or denominator. Step two, we want to replace the quotients of factors common to the numerator and denominator with 1. So in other words, you're basically going to cancel any common factors in the numerator and denominator by realizing that they're just going to equal 1. And then you multiply the remaining factors in the numerator and remaining factors in the denominator. Now on my examples, I don't usually multiply them out at the end, but you can. And then of course make sure that your example is written in lowest terms. Now so I'm going to start you here with just a simple one. These fractions only have one term in the numerator and one term in the denominator, so there really wouldn't be any reason to factor these. So what I can do here, I mean, you can cross cancel, do what's cross canceling here. It's a kind of a little shortcut, but to avoid confusion, let me just show you what I'm going to do. I'm just going to multiply the numerators together. So I have 3 times 10, which is 30, and then I have x squared, so I'll just put 30x squared. And the bottom I have 5 times x cubed, so that's just going to be 5x cubed. Now what I'm going to do next is, I know that 30 can be written as 5 times 6. So if you think of that, see if I can write that. That's not a very good looking 5, is it? So 30 is 5 times 6. And so you can actually cancel the 5 into the 30 and you'll be left with 6. So that's where the 6 came from. Now I have x squared in the numerator and I have x cubed in the denominator. So remember, x cubed can be written as x squared times x. So that way I can cancel the x squared here, and because x squared over x squared is 1, and then but I still have a factor of x in the denominator. So that's going to just simplify to 6 over x for that one. Now on this next one, you'll notice here in this denominator I have multiple terms, and in this denominator I have multiple terms. So there I want to see if I can factor. So what I'm going to do here is I'm going to take the 2r plus 4, and I can factor a common factor out, and that's going to be 2 times r plus 2. And then I'm just going to multiply that by 3r, or I'm actually just going to show it, 3 times 3r. And then on the bottom, I'm going to take the 5r, move it over here, and multiply it by the 5r plus 10. But first I want to factor out a 5 out of this. And so I get a 5 times the quantity r plus 2. Now I want to find any common factors here. I know that r plus 2 over r plus 2 is 1. I know that r over r is 1. And I believe that's all I can do now. So let's see what I have left on top. I have 2 times 3, which is 6. And on bottom, I have 5 times 5, which is 25. So this just reduces to 6 over 25. All right, let's do another example. Here, I have a binomial here and a trinomial here, and then I have a binomial in both denominators. Well, let's go ahead, and I just copied this down here. I could have just went straight to the example, but I thought it would look better if I copied this down. So here I'm going to just factor out a c. So factor out the common factor of c, and I have c times c plus 2. And then this trinomial actually factors, it'll factor into c minus 2 times c minus 2, which is c minus 2 quantity squared, but I thought it would be better just to leave it like that as c minus 2 times c minus 2. And then c squared minus 4 factors into c plus 2c minus 2, and then I factor the c out of c squared minus c, and I got c times c minus 1. Now you'll notice I tried to highlight the things that will cancel here. For instance, you'll see the C is in bold here, and that's because it'll cancel with this C here. And then this C plus 2 is in bold, and it'll cancel with this C plus 2. And then this C minus 2 here will cancel with this C minus 2. And then I'm just left with a C minus 2 on top and a C minus 1 on bottom. Looks like I did a typo there. So that's a C, that should be a C minus 1. So make that a minus right there. So, all right, so it should be C minus 2 over C minus 1, and the C minus 1 is what you should have in the denominator. Okay, so on this one, I have r squared minus 9 over 4 minus r, and here I have r squared minus 4r over r plus 3. Well, I know r squared minus 9 factors into r plus 3, r minus 3, and I can factor an r out of this and get r times r minus 4. Now, what I did here is this 4 minus r, I didn't like it written that way. So if you factor a negative 1 out of this, then that would change the sign of 4 to negative and the sign of r to positive. So by factoring a negative 1 out, this becomes r minus 4. So here's the negative 1 that I factored out, and then there's the r minus 4. And then from the other fraction, I have the r plus 3 multiplied there. Now again, I tried to highlight those things that would cancel, like the r plus 3 cancels with the r plus 3, and the r minus 4 cancels with the other r minus 4. And so what I have in the numerator is r times r minus 3, and then in the denominator I have negative 1. Well, I don't have to leave it like that. I can actually just write this, move the negative 1 up here, and then make that minus r times r minus 3. So minus r times r minus 3. Now you could distribute the negative r through if you wanted to and get negative r squared plus 3r, but I'm okay just leaving it like that. So like I said, if you know how to multiply rational expressions, you can certainly divide them, because what you do, same thing that you did with regular old numbers, when you divide it by a fraction, you just flip the fraction over and multiply it. So here, 16k squared over 5 divided by 3k over 10 is going to be the same as 16k squared over 5 times the reciprocal of 3k over 10, which is 10 over 3k. And then if I multiply these two together, I get 160k. Well, actually, I'm sorry. If I multiply them together, I get 16k squared times 10. And on bottom, I get 5 times 3k. Now, what I did first here is I went ahead and said k will cancel into k squared. Since k squared is k times k, one of those k's will cancel, and that'll leave me with a k here. So now I have 16 times 10, which is 160, and I have the k, so I have 160k over 15. And then all I had to do now is say, okay, well, 15 is the same as 5 times 3, and 160 is the same as 5 times 32. And so if I cancel the 5's, because 5 over 5 is 1, then 5 times 32 over 5 times 3 is just going to be 32 over 3. So with the k, that gives me 32k in the numerator and 3 in the denominator. Now in the next expression, again, the first thing I want to do here is go ahead and flip it and change it to multiplication. Now you can flip and factor at the same time, but it might be confusing, so I suggest, especially on your first examples, to go ahead and flip it first and then do your factoring. So I've flipped it here, so now let me factor this. Y squared minus 2y minus 3 factors into y minus 3y plus 1. Y squared plus y minus 2 factors into y plus 2 times y minus 1. Y squared plus 4y plus 4 factors into y plus 2 times y plus 2. And y squared minus 1 factors into y plus 1 y minus 1. So looking at the numerator, I can see that y plus 1 will cancel with y plus 1, and y plus 2 here will cancel with this y plus 2, and then this y minus 1 will cancel with this y minus 1. So all that leaves me with is a y minus 3 in the numerator and a y plus 2 in the denominator, so that's my answer. Now, I'm going to end this with one where you have three rational expressions, and notice we're multiplying the first two, and then the second one we're dividing. So what I want to do first, before I do anything, is I want to go ahead and flip this one over, since this is the one that we're dividing by. So I'm going to flip it over. If you'll notice down here, you'll see that I flipped it over, and then I changed everything. I changed this to multiplication. So now I'm going to factor each of these numerators. M squared minus 1 factors into m plus 1, m minus 1. Now I realize it'll take you some trial and error or using grouping method, but you should be able to factor these. It might take a little while, but you should be able to factor these two trinomials. The first one factors into 5m minus 3 and m plus 4, and the second one factors into 5m minus 3 and 3m minus 5. Then down in the denominator, 25m squared minus 9 factors into 5m plus 3, 5m minus 3. And then 3m squared plus 7m minus 20 will factor into 3m minus 5 and then m plus 4. And then 5m squared plus 2m minus 3 factors into 5m minus 3 times m plus 1. Now let's start looking for things that will cancel in the numerator and denominator. I have an m plus 1 that will cancel with this m plus 1 way over here. I have an m minus 1. I don't see an m minus 1 in the denominator. I have a 5m minus 3 that will cancel with this 5m minus 3. I have an m plus 4 that will cancel with this m plus 4. And I actually have a 5m minus 3 again, and I have a 5m minus 3 again in the denominator. And then let's see, what about 3m minus 5? Yeah, I have a 3m minus 5 in the numerator and a 3m minus 5 factor in the denominator. So that's going to leave me with m minus 1 in the numerator and 5m plus 3 in the denominator. And so there's your example of how to multiply and divide rational expressions. I wanted to just remind you before I leave this section that when you're doing all of this canceling from the numerator and denominator, remember you're canceling factors. So that's allowed. Like here, x plus 3 over x plus 3 is 1, and you can just write the result as x minus 1 over x minus 5. But look over here, a common mistake that students make is they think they can cancel terms. But here, you might think you could cancel the x with the x. But see, you can't do that because this is a term, not a factor. So actually, you couldn't do anything with this in terms of canceling anything, because that would be, would not be correct. An example of that would be like, suppose you had 3 plus 6 over, I don't know, let's say 3 plus 9. Okay, well, you can see that the way to do that would be 3 plus 6 is 9, so that would be 9 over 12. 3 plus 9 is 12, which reduces to 3/4. Okay, but if you did try to cancel the 3's, you would get an answer of 6 over 9, which is 2/3, which is obviously not the right answer. And it's not correct because you're not allowed to cancel these 3's here because these 3's are terms. They're not factors. So hopefully that'll save you some grief on working some of these problems. In the next section, I'm going to talk to you about adding and subtracting rational expressions.